third graders. Today we are working on math lesson 23. So we need your pink problem set, lesson 23, and name and date on there. And our I can statement for today says I can solve a variety of word problems with perimeter. So you might want to grab your highlighter if you don't already have one handy. And because we know with word problems, we have RDWW, so we want to highlight those clue words and those extra things that kind of help us to figure out what we need to do. Alrighty, are you ready? So number one, go ahead and put your finger or your pencil on number one. And we know that since this is a word problem, this is going to be RDWW, so we can get that set up and ready. And let's start our read, okay? So go ahead and put your finger or your pencil on Gail. Here we go. Gail makes a miniature stop sign, a regular octagon, with a perimeter of 48 centimeters for the town he built with blocks. What is the length of each side of the stop sign? Okay, so I read it. I need to go back through and pull out important information now. So he makes a miniature stop sign. What shape is a stop sign? It's an octagon, and they actually tell us that right here. But more specifically, it's a regular octagon. Let's highlight that word regular, or at least circle it. What does it mean if it's regular? If a shape is regular, what does that mean? It means it's like the traditional shape. So a regular octagon does look like a stop sign. But if a shape is regular, that means all sides are equal, right? Good. So we know that all sides of this octagon are going to be the same. They're going to be equal. And this shape has a perimeter of 48 centimeters. So the distance around the outside of the octagon is 48 centimeters. So he makes a miniature stop sign, a regular octagon with a perimeter of 48 centimeters for the town he built with blocks. What is the length of each side of the stop sign? So there's that clue word each. Each tells us that we're going to multiply or divide, right? So we can highlight that word each. Okay. And I can check that off. All right. In this case, so we know that each tells us that we're going to multiply or divide. So we need to think to ourselves, do we know the total? Because if we know the total, then we are going to divide. If we don't know the total, we're going to multiply. So if I look back through, he made a miniature stop sign, regular octagon with a perimeter of 48 centimeters. So is this 48 centimeters, is that the total or is that one of the sides? This would be the total, right? Because the perimeter is 48, so the distance around the outside of that octagon is 48, so that would be the total, okay? All right, so let's go ahead and do our draw. So we want to draw our stop sign, our octagon, so we know that it has 8 sides. So to make a regular octagon, let's build our top part first. So it looks like that, the top part of it, which is kind of like the top part of the trapezoid. If I were to just draw that bottom line right there, I would have a trapezoid, right? So I have 3 parts, and then I come down. That gives me 5. So 1, 2, 3, 4, 5. And then for the bottom, I'm going to come in 6, 7, and then connect it for 8. Okay. So then just check after and make sure that you have 8 sides. So 1, 2, 3, 4, 5, 6, 7, 8. So there's my octagon. And I know that this whole thing, the whole outside of it, equals 48. And how many parts are there? There's 8. So I did my drawing. I know that the whole thing equals 48, and I want to find what each one of these sides equal. So what would I do? We said we see the word each, which tells us that we're going to multiply or divide. We know the total, so that tells us that we're going to divide, right? Go ahead and write down what you think that the number sentence would be to find the length of each side. What do you think? So it would be 48 first, right? Because that's the total. Did you divide by 8? Yeah, we would divide by 8, right? Because there's 8 sides of our octagon, and we want to find what each one of those sides equals. So if I do 48 divided by 8, that would give me the length of each one of these sides. So what did you get for your total there? 8, 16, 24, 32, 40, 48. So each side would equal 6, right? 6 what? 6 centimeters. So I can add that to my picture, that each one of these sides would be 6. Okay, so then I can check off my W. I wrote my number sentence, and my last W would be to write a word sentence. So what is the length of each side of the stop sign? So I'm going to write it in cursive if you'd like to join me. So each side is 6 centimeters. Each side is 6 centimeters. Good. And we know that's definitely miniature because if you think of a ruler, centimeters is the little side. So if I have a ruler, I have my ruler right here. So 6 centimeters, while you're finishing that up, would just be this much right here, from here to here. So each side of the stop sign, of Gail's stop sign, miniature stop sign that she made, is 6 centimeters. So it would only be this much. So we know that that's definitely not a real stop sign, right? Because a real stop sign, each side would maybe be like this long, right? Okay. Good. So when you're finished with number 1, you can move on to number 2 with me. If you're finishing up here, just go ahead and pause your video and join me when you're ready. All right, number 2, Travis. Put your finger there and follow along. You can read with me out loud if you want to. Okay. Travis bends wire to make rectangles. Each rectangle measures 34 inches by 12 inches. What is the total length of the wire needed for 2 rectangles? Ooh, right off the bat, I know that I'm going to draw 2 rectangles. We don't want to miss that because we may, a lot of times kids maybe just find the perimeter of the one rectangle, but we need the perimeter of 2 separate rectangles. So this is RDWW, right? So let's get that set up. Okay. So he bends wire to make rectangles. Each rectangle, there's a clue word, each rectangle measures 34 inches by 12 inches. What is the total? There's another clue word. What is the total length of wire needed for 2 rectangles? So there's our read. So next is our draw. What do you think that we would draw for 2? Let's give me what I want to say. What do you think that we're going to draw for this picture? I kind of started to say it, right? We need to draw 2 rectangles. So let's make 2 rectangles because it says what is the length of wire needed for 2 rectangles? So we'll make our 2 rectangles. Okay. And it says each rectangle measures 34 inches by 12 inches. So I need to label. So 34 inches by 12 inches. So would 34 go here or would it go here? I want to label the longer side 34 because it's 34 by 12. So that means my short side here would be 12, right? So 34 by 12. Now, do I just need, I'm going to find the perimeter, right? Because he's bending wire to make the rectangles, and I want to know how much wire he needs. So that means that we're finding the perimeter. It doesn't say perimeter, but that's really what we're doing, right? So do I just need the 2 sides to find the perimeter? I need all 4 sides, right? So what do? Do I know what this side right here would be? This would also be 34, right? Because in rectangles, we know the opposite sides are equal. So if this side is 34, then this side is 34. Do I know what this side right here would be? Would it be 34? Nope. Would it be 12? Yes. Okay. Because in rectangles, again, opposite sides are equal. So if I know that this side is 12, then this side is also 12. Okay. Now, how about for this second rectangle here? Do I know what these side lengths are going to be? It's going to be the same, right? Because it says that he makes, what is the total length needed of wire needed for 2 rectangles. So he's making 2. So we're going to label this exactly the same. 34, 34, 12, and 12. What do I do now? I just need to add it up, right? Now, you could add up all of these numbers together, or if I find the perimeter of one rectangle, what's the perimeter of this one going to be? It would be the same. So if we just find the perimeter of this one, I know that this one would be the same, right? So it's going to be 34 plus 34 plus 12 plus 12, or I could say 34 plus 12 is, and if you want to pause it, you could pause it and do this work on your own and then check with me. There's a bunch of different ways to do this, okay? 4 plus 2 is 6. 3 plus 1 is 4. So these two parts right here equal 46, 34 and 12. So here is 34 and 12 again. So what are these two parts here going to equal? 46, right? Because it's the same numbers. So I'm going to add, so this is just, I'm just kind of doing this, but it would be if I did P equals 12 plus 34 plus 12 plus 34. 12 plus 34 equals 46. 12 plus 34 again equals 46. So what do I do to find that perimeter? I'm going to add those two numbers together, right? So 46 plus 46. Let me stick it down here. We don't have much room, do we? 46 plus 46. 6 plus 6 is 12, right? 2 carry the 1. 4 plus 4 is 8. Plus 1 more is 9. So that would be 92, don't forget your label, inches. So the perimeter of this equals 92 inches. So if this one equals 92 inches, what does this one equal? 92 inches, right? So we can put the same thing. P equals 92 inches. Am I done? No, I need to find what the total would be of both of these rectangles because I want to know what is the total length of wire needed for 2 rectangles. So I'm going to add 92 plus 92. Okay, so 92 plus 92. 2 plus 2 is 4. 9 plus 9 is 18. So that equals 184. What's my label? Inches, right? 184 inches. We can check off our drawing because we did that. We can check off our number sentence because we wrote plenty of number sentences. The last thing is our word sentence. We don't have much room. I'm going to have to squeeze it in tiny. What is the total length of wire? So he needs, I'm going to squeeze it in right in here. So he needs 184 inches. You see that in there? I just squished it right in there. He needs 184 inches. We'll just keep it nice and short since we don't have a ton of room. Okay. Alrighty, when you're ready for number 3, you can join me. If you're still on number 2, you can pause your video and finish up. So number 3 says the perimeter of a rectangular bathroom is 32 feet. So we know it's a rectangle. So I'm just automatically getting that visual in my head that I'm going to be drawing a rectangle. So maybe I'll just do it now. Since I'm already thinking it, I might as well do it, right? And the perimeter of the bathroom is 32 feet. So that means that this whole thing equals 32 feet. The whole thing around is 32 feet. Okay, so the perimeter of the rectangular bathroom is 32 feet. The width of the room is 8 feet. What is the length of the room? Okay, so we know this is RDWW, right? We did our read, right? We started our draw, okay? So it says that the width of the room is 8 feet, okay? So we can mark 8. And if this top side is 8, what's the bottom side? 8, right? So the width of the room is 8. What is the length of the room? So let's see here. And it doesn't really matter where you put your 8s for this one, okay? What are we going to do? We want to find these missing side lengths here. So what do I do? What would I do? Remember our last lesson where where we knew the perimeter, right? So we added the 2 side lengths that we had, and we found that total, and then we subtracted that total from the total perimeter. Remember? And then we took that number and then we divided it by 2 because there was 2 missing sides. Do you remember doing that? This is going to be the same thing that we're going to do right now, okay? So we know that the 2 side lengths here are 8. So between these 2 side lengths and these 2 side lengths here, it has to add up to 32. So let's add 8 plus 8, which we know equals what? 8 plus 8 equals 16. So these 2 sides equal 16. But I need to know if I subtract 32 minus 16, what does that give me? Because that would be the length that these 2 would add up to here. So maybe you can do mental math, but it would be a good idea to write it to check as well. 32 minus 16. Okay, can we do 2 minus 6? No. So I'm going to cross out the 3 and make it a 2. And this 2 becomes a 12. 12 minus 6 is 6. And 2 minus 1 is 1. Okay, so these 2 sides here are going to add up to 16. Okay, so I'm going to take that 16 and I'm going to divide it by 2 and see what that equals. And that would tell me what the length of each side is. Okay, alrighty, so 16 divided by 2 equals 8. So these would equal 8, right? Yeah. So the question says, what is the length of the room? So it would be 8. Now, if this would have said, because actually what shape did we end up having? We ended up having a square. So this is more, we drew a rectangle, right? Because it says a rectangular bathroom. So that's okay. But if it really ends up being a square because all sides are equal. Now, if it would have said right off the bat that it was a square bathroom, then we would have known that all sides were the same. So then we could have just taken that 32 and divided by 4, since there's 4 sides of a square and all sides are the same. But we didn't know that it was a square right off the bat. We just knew that it was that rectangular shape, that it had 4 sides, but it didn't tell us that all sides were equal. So we had to do that work. Okay, so the question was, what is the length of the room? So it is 8 what? 8 feet. Okay, so let's look here. We did our read, we did our draw, we did some number sentences. Our last thing is to write a word sentence. So I go back to the question, what is the length of the room? So the length, and I'm going to write in cursive if you want to practice with me. So the length is 8 feet. And that's it. So I don't know about your paper, but when mine printed, it was just the front. Does yours have a back to it? Because if it does, it's your lucky day because we're just doing the front. I know that there definitely was a back to this, but it didn't print. So we're just going to stop right there. So that is our lesson for today. Okay. So I think this was a good review though. We kind of took everything that we've worked on with perimeter in this unit and we kind of combined it. So we found what each side would equal. We found total perimeter. We found missing sides. So this was, even though it was just 3 problems, that was a good, and look at all the work we did too. So I think we did a good job today. All right, super job, guys, and I will see you later for some more math.